Hello, everyone. Welcome to our speaker series on databases in paleontology. My name is Elizabeth Dowding from the Paleosynthesis Project here at FAU Nuremberg Erlangen University. And with me today is Emma Dunn, also at FAU. And our invited speaker today will be introduced by Emma. But just as an introduction to the series, we will be exploring the structure of large-scale data sets and open data initiatives, as well as innovative database technologies. And these together are revolutionizing our understanding and altering the way that we do science. Paleontology is becoming increasingly digital, and with this speaker series, we really hope to explore the data needs of the discipline and to consider the opportunities that it provides for us as we move into the future. So yeah, thank you, and take it away, Emma.
Hi, everyone. Thank you so much for joining us today. It's my pleasure to introduce our very first speaker, Dr. Na Lin of Nanjing Institute of Geology and Paleontology in China. Na Lin is going to speak from her position as data manager of the Geobiodiversity Database and also her extensive research on Cambrian biodiversity, which I've been told she'll introduce more herself. Na Lin, thank you so much for joining us, and take it away.
Thank you for having me here. So I'm going to share my screen, right?
Yes, please.
So can I see it? It's okay? Okay. Okay, I'm going to start now. The Geobiodiversity Database, aka GBDB, is a digital data repository for stratigraphy and paleontology. And I am very honored to be invited here today to give an introduction about the database itself. So basically, this talk is going to be around how and why it was established in the first place, and what about it now, and what we can do with it in the future. Okay, but who am I? My name is Na Lin in Chinese order, so you can call me Lin as well. I got my master's degree in Nanjing Institute of Geology and Paleontology in 2011, working on early Cambrian biostratigraphy based on small shelly fossils. In 2011, I got this opportunity to go to Germany as a PhD candidate tutored by Professor Wolfgang Kiesling, researching on diversity patterns during the Cambrian radiation, and got my PhD degree in 2016 at University of Erlangen. The same year, I got this assistant professor position in NICPAS. And with a big data center was established in NICPAS in 2018, I was trusted to be partly responsible for the maintenance and development of the GBDB. Then became the data manager of the GBDB in 2021 and start leading a small team specialized in data governance. Also, I'm interested in database rooted analysis on large-scale paleodiversity and paleoecology, and currently I'm mainly focusing on the Cambrian and Ordovician. Okay, for starters, GBDB has a nearly 20 years history. It was initially established in 2006 in NICPAS, went online the very next year, but it was not until 3 years later when they start entering first data. Original GBDB team was led by Fan Juanxuan, who is specialized in Ordovician stratigraphy. The primary research goal of the GBDB was to provide an integrated system for the management and analysis of stratigraphic and paleontological data. So basically, its main purpose was to carry out stratigraphic related analysis, such as how to align regional and global stratigraphic record and make out standards for global stratigraphic division and correlation, as well as how the incompleteness of stratigraphic record, such as stratigraphic hyostes, affect our reading of the fossil record and thus biodiversity. Also, the evolution of depositional sequence through time and across space was also one of the main original objectives. An initial compilation starts with the data only from China, with sources coming from publications on stratigraphy and paleontology, including both published and unpublished. In 2012, the GeoBDB became the formal database for International Commission of Stratigraphy. And next year, the GeoBDB team held a second international symposium on quantitative stratigraphy. Actually, the first one was held in 2010, but the second one included a short course on the GeoBDB. And at the short course, a very important analytical tool for stratigraphy was shown how to integrate with the GeoBDB. It is called the constraint optimization. CONOP is a software program for stratigraphic analysis designed by Peter Sadler. And during this period, the GeoBDB is widely known but not widely used. Nevertheless, there were still a few good works on carrying out stratigraphic correlation and paleogeographic reconstruction emphasized on using the GeoBDB data. Then time comes to 2018. The whole FANS group left NICPAS, went to Nanjing University, and there was a big changeover of team members. This is also when I got involved. It was a chaotic time, no shame to say that, not only because it was quite a sudden turn of event, but also because the website of the GeoBDB has come to a kind of bottleneck period due to its outdated system and also the difficulty to freely access the database for most of users. And one of the biggest and priority problem at the time was the fact that GeoBDB does not have geochronological ages for nearly all data. Therefore, in 2019, our team worked with the PBDB and aimed to retrieve the age from the PBDB based on same geological formations, as well as making collaborating plans between these two databases. After 1 year's effort, the new GeoBDB went online in 2020. The new homepage has a more modern style and user-friendly web interface. The search engine is not perfect, but working okay. With age information, we can search sections by different timescales. However, at this time, data input and download was still far from being ready to use. That is being said, data can neither be input or downloaded without any problems, not to mention systematic bugs that always get in the way. Therefore, since 2020, we've been devoting our time and energy on making the website applicable and accessible. For example, 2021, we online the new download page. Also, the input page gets improved, and other built-in analytical tools are gradually recovered. Last year, it is such an honor and pleasure for us to join sub-projects within paleosynthesis umbrella, and this opens a big opportunity for the development of the GeoBDB in the future. Okay, now let's get to the part where the database is really about. Firstly, let's meet the team. Our team is very small, but relatively young, with 2 researchers, me and Qijian, 1 technician, 2 interns. Qijian is specialized in the observation reefs. He is a well-trained sedimentologist and has been involved in the GeoBDB since 2018 with me. The technician, Ming Han, has been with us nearly 2 years and is responsible for GeoBDB web development. And 2 misses here are very skilled data enters, since they have years of experiences in assisting researchers in NICPAS to compile data to the GeoBDB. The structure of the database. GeoBDB is section-based, in other words, stratigraphic columns, representing measured bed-by-bed records of rock and fossil collections with their geological contexts. The design of the GeoBDB was actually inspired by some other databases that already been out there for a while. Two most important ones are the successful attempts of PBDB and MacroStrat. The PBDB is global inventory of fossil occurrences in their geological and stratigraphical context. MicroStrat documents the macrostratigraphy of North America and the Caribbean. Therefore, structurally speaking, the GeoBDB can be viewed as a combination of these two databases. Now let's take a look at an example in the GeoBDB. This is a stratigraph column portraying Xinjiapo section from Shanxi province of China. It is Cambrian stage 3 of age. The way that the GeoBDB stores this type of data is to divide the measured section into several geological units according to the described changes in lithology from bottom to the top. If there are fossils sampled from a unit, then a fossil collection will be recorded as well. That is to say, one section may contain several lithostratigraphic subdivisions and several fossil collections, and each collection may contain several fossil occurrences with their taxonomic information stored in the database as well. So basically, the GeoBDB is structured with several datasets, including taxonomy, occurrences, lithostratigraphy, biostratigraphy, chronostratigraphy, and chemostratigraphy if geochemical data is provided, as well as bibliographic references and basic geography with modern and paleo coordinates. And in this way of compiling, not only that we have bed-by-bed occurrence data from rock layers during a particular time interval, but also that the sampled but unfossiliferous sedimentary stratum will be also well recorded. As for the technology of the GeoBDB, different from the old static HTML-based web, front-end of the new website is created with React.js, which is a fast and stable JavaScript library used to build complex user interfaces for websites, and thus can build more dynamic pages than HTML. The backend development is using Node.js to create web applications that take calls between front-end and database. And the database is using MySQL system to manage and run data stored as tables. Funding. Throughout the years, the development of GeoBDB has been heavily funded by Chinese Academy of Sciences and the State Key Laboratory of Paleobiology and Stratigraphy in NICPAS, especially for the early years during the establishment. Currently, NICPAS is still strongly supporting the GeoBDB, but funding it less by less. Next, let's take a look at the scope of the data. This figure shows the increment of data for the past 14 years. Here I only show the section and fossil collection in numbers. For the first several years, we can see the data input increased rapidly. But since 2018, the increment of data almost stopped because of the renovation. At the moment, the GeoBDB comprised about 25,000 geological sections and nearly 600,000 fossil occurrences ranging from the Ediacaran to the Quaternary. About 1/3 of data has been assigned into a geochronological ranges by cross-examining with the PBDB. And from the figure on the right side, we can see the Ordovician and the Permian have obviously more extensive data input compared to other time intervals. More than 70% of sedimentary units are marine. The Paleozoic data are almost all China, so are nearly all marine. the post-Triassic data in the GBDB are dominant with non-marine sediments. This calculation is based on only about 1,200 geological formations that can be confirmed by the PBDB. And for the whole data, the proportion of marine record could be higher because of the priority of Paleozoic data, especially the data from Ordovician and the Permian in the early funded research projects. Geographically, about 86% occurrences are from China, in which most are from South China. And taxonomically, the dataset contains various fossil groups, including protists, animals, and plants. Plants only account for a very small part of all occurrences. Among animals, conodonts are the most abundant, followed by graptolites, brachiopods, trilobites, and other animals. There's this kind of a bias in faunal composition in GBDB toward taxa with important biostratigraphic implications. Last but not the least, applications. By applications, I mean, what can we do with GBDB data, or what kind of questions that GBDB can allow us to explore? Firstly, diversity analysis. One of the reasons that it was difficult to use the GBDB for most of users earlier is its lacking of geochronological ages. Another reason would be that the downloaded datasets were independent from each other. That is to say, one cannot link occurrences number to its belonged geological formations, and thus to its belonged age and section and location exactly. Therefore, the GBDB data back then was not suitable to do chronostratigraphic analysis in diversity studies. But the situation is changed now. With the new download page, we can freely get datasets of occurrences, collections, and the geological structure. And these three tables are linked through a unique unit ID. In that way, all documented information about a single occurrence, such as locality, age, geology, taxonomy, are complete. And we can select data by taxa names, by time, by locations, and by formation names or section names, just as similar as in PBDB. With collection and occurrence data downloaded from the GBDB, we can lump together fossil collections over relative geological timescales, and we can see how the diversity curve after sampling standardization changed through time. Secondly, stratigraphic correlation. As I mentioned a little bit in the beginning, CORNOP is a software program for compiling biostratigraphic ranges to simulate and generate the most possible combined sequence from a set of sections. Now the download function for CORNOP is also available in the GBDB, and we can simply search the targeted sections and add them to a subset in the account like a drawer, then go to the subset, select those sections, and click the export to CORNOP files button. Because the data have been automatically arranged by the system for the CORNOP, so you will get 4 files that are required in running CORNOP. In these files, you can modify the data as you want, and copy the CORNOP program in the same folder and start the analysis. Depending on the number of sections, it will take seconds to minutes or even days to complete the program. Normally, for sections less than 10, it takes less than a minute with the help of a modern personal laptop. Eventually, it will give you a diagram depicting how those sections are arranged to correlate it with each other biostratigraphically. With this approach, the age could also be resolved to an average bed if there is a radiometric dates or other geological data that can imply absolute age. Based on more than 11,000 marine vertebrate species from about 3,000 stratigraphic sections, a FANS team produced a high-resolution Paleozoic diversity and published related results on Science in 2020, which has been a breakthrough for the GBDB. Resulting curve has been generated through calculations of billions of iterations per run to allow the production of the precise genus and species level diversity curves for different fossil groups. A running corner program on thousands of sections require very high computing power. It is surely a hard time to replicate, but this approach provides the potential of the GBDB in establishing finely resolved traceable time beams over wide geographic areas. And the third important application of the GBDB data is to integrate a geographic information system, GIS, to build quantitative paleogeographical reconstructions. It is a way to visualize regional and global paleogeographic features. Here is an example from a most recent work, also by FANS group. The three-dimensional paleogeographic reconstructions of South China is built on about 800 sections from the GBDB. And from the figure on the left, we can see that the timing and the process of major transformation of the land-sea distribution through the whole observation is precisely reviewed. Well, with all that being said, there are still many issues remains in the GBDB. Firstly, we do not have detailed taxonomic affinities for most of the taxa in the GBDB, only a general taxonomic group. And secondly, there are still nearly 60% of data lacking of geochronological ages as well as environmental information. And we also have redundancy problem for the references that exist in more than one databases out there. Like how do we identify the replication of the data if we want to use different databases to compensate for each other? The ecospace data is also missing, and there is about 20% of references in the GBDB were not peer-reviewed. Moreover, the whole procedure of data input is also a little bit complicated. This would make users get wary to trying the GBDB for starters. And technologically, the backend language that we are using in the GBDB is a light-weighted one, which means that with very heavy computational tasks, its performance will get reduced. And lastly, lack of funding, but I guess it is for everyone. In the future, for the sustainability of the database, we will keep on improving utility and accessibility of the GBDB to serve a better and hopefully wider use for users. Also, we'd love to share our data to achieve a global integration for paleontological data. So we will keep enhancing the interaction and cooperation with other databases. We also need to expand our data coverage. For example, include more data from outside China, more from post-Permian period, as well as geochemical data. And for the science part, apart from carrying out stratigraphic correlation and paleogeographic reconstruction with both the fossil record and geochemical proxies within a clear stratigraphic scheme, GBDB data is also useful to do high-resolution correlation between biological events and environmental changes, such as climate changes, and eustatic sea level changes. And also paleoecological studies, for example, nature evolution. I can give you a few examples. So here's a recent science attempt by us in which instead of compiling lithology and fossil data from different sources, we are using GeoBDB data to trace changes in numbers of rock quantity and biodiversity on the same page and test the strength of rock volume bias in evaluating biodiversity in deep time. Another attempt would be ecological nature modeling. Here's an example. This paper is using ecological nature modeling analysis under a late Ordovician crinoid. And such nature analysis requires geographically explicit information on species occurrences and inherent environmental conditions for each occurrences. And with the environmental data from the rock layers in which the focal taxa occur, habitat suitability can be quantified across space. And applying this similar analysis on GeoBDB data might also help to quantitatively test hypotheses of species-environment interactions at biotic events. Additionally, GeoBDB data may also be used to even explore when and how do species achieve niche stability over long-time intervals. Anyway, I'm not going to get into the details here. I just want to show you the potential of the GeoBDB in answering evolutionary questions. And in one word, GeoBDB can provide both fossil occurrences data and environmental data in the whole package with bed-by-bed resolution. And the potential would be bigger if working with other databases like PBDB. Okay, this is my last slide of the talk. Many thanks are given to people who have supported the GeoBDB in various ways. And also thanks for including us to this great project in IRAL. I hope through this talk, GeoBDB becomes a little bit more clear to you. If anyone has any problems with using GeoBDB at the moment or in the future, please feel free to contact us. And any suggestions in improving the utility of the GeoBDB are welcomed. And we are also more than happy to talk about any potential science projects. Thank you. Thank you for your attention.
Thank you so much, Na Lin. That was absolutely fantastic and so great to see how it's been developing over the last few years. We've already got lots of questions, so if you're ready, I'm just going to dive straight in. So I think the first one that I'll get to is linking up the GeoBDB and IRL. So IRAL, even I get it wrong sometimes. So Daniela asks, can you explain the role of the GeoBDB in the IRAL project? And I can also answer this if you want to go ahead and start.
Oh, yeah. I think the role of the GeoBDB in IRAL project is to provide more data formats to the whole paleontological world. And I hope through this project, the GeoBDB can expand their scope of utility and maybe be more useful in the future.
Yeah, so for those who may not be aware, the IRAL project is short for the Integrated Record of Ancient Life, and it's a project that Paleosynthesis is supporting, where we are hoping to look at how we would integrate the databases that we use for paleontological research. And you can find out more information on the Paleosynthesis webpage. And maybe Liz, you could drop that link into the chat while we get to the next question. Cool. I'm going to continue on to Daniela also has a technical question. Can somebody who's using the GBDB filter occurrences to exclude taxa with uncertain taxonomic affinities, similar to how you can currently with the paleobiology database?
I mean, the occurrences data in the GBDB data, GBDB, what?
Yes.
I will see the. Can you repeat the question?
Sure. Can you filter the occurrences to exclude uncertain taxonomic affinities?
Yeah, okay. Right now, we can filter the taxonomy with the uncertain taxa, just like in PBDB, the uncertain taxa, also the taxa with a lot of affinities. Yes, we can filter it in taxonomy, but in our download page, if you want to filter the data through the taxonomy, we now can provide only filter the names of the taxa in genus and in species, if you know what I mean. Because in GBDB system, originally, we don't really have a lot of taxonomic information about the hierarchy of the taxa. We only group them into several general taxonomic groups like trilobite, like a brachiopod. This is a setback of the GBDB, but we are improving to completing this kind of information now and also in the future.
Sounds great. I'm going to go to the next question from Baran. What is the easiest way to subset marine lithology records from the GBDB? You mentioned the PBDB. Did you subset marine records using marine fossil occurrences, or how did that work?
No, we are not using the fossil occurrences to separate marine from non-marine. We are using the geological formations. This is also done by recently, because we have a paper submitted to a journal, and they ask us to separate the marine and the non-marine sediments. In that way, the result will be more meaningful or insightful. And the things we did is to using the geological formations, cross-examine with the same ones in the PBDB, because in PBDB the formations have the environmental information. So we use the PBDB to give the GBDB formations environmental information, but just the marine or terrestrial, not very in detailed environmental information. So yes, now we are using the PBDB formations to separate our marine and non-marine. So, but it will be a very big task if we revise the occurrences or collections in the GBDB one by one, piece by piece, because it will take a lot of energies of us. So this is the easiest way for now to separate the marine and non-marine.
Fabulous, thank you. Moving away from technical based questions to more broad scale patterns, what do you think is the biggest advantage of using stratigraphical information as the foundation of the GBDB? Because the other databases don't tend to focus like that. What's the biggest advantage in your experience?
I think the biggest advantage of using the stratigraphic framework of the GBDB is that we not only record the occurrences, we also record the rock record with fossils or without fossils. So that will give people a more combined or comprehensive information about the environments where the fossil remains, and also we can use this kind of a data frame to correlate the fossils evolution and also the geological evolution in the background. So I think this is what PBDB alone and MacroStrat alone cannot do. So yeah.
Yeah, sounds great. Another broader scale pattern question. Alex asks, in your experience, how important is it to have full-time engineers working on the database?
We have a full-time engineers working on this. It's I don't I'm not him, so I can't speak for him. But I think he has because the technician is very new, is very young, and he's been with us only from 2020, 2021, so less than 2 years. And when he was originally involved, he knew nothing about GBDB. He has to learn how to use the Node.js, because before that the new website is online and using the technology is already out there, and he has to adjust to this the whole system, and he has to learn new language to manage the database. And but for us, I think the one most difficult things for the technician to manage the database is that the Node.js, the backend language, is lightweighted, and this will require a lot of effort if you want to improve a function or an application in the database, and it will cost his time and energy on adjusting the coding things. I'm not very familiar with it, but for example, before we have this TS creator to create the timescale stratigraphic columns from the data stored in the GBDB. I know we copied the stratigraphic column from the reference in the database, and then we can create another column just using the TS creator. And because this application was existed in the old GBDB, but when the new one went online, it was lost in the middle of transferring the functions. And I think it's really important. It's really important for people to check the data. So I asked him to redo this kind of TS creator application just to integrate into the GBDB, and it cost him almost 2 months to finish it, and now it's still not very perfect. So that's yeah, I think it's difficult, but we're lucky that he's full-time technician here. It's not part-time. So yeah.
That sounds great. It sounds like a big learning curve for him too. One of our final questions is, you mentioned at the end of your talk the lack of funding, which all databases seem to be suffering from. In your opinion, what would an ideal world situation look like for database funding? I'm sorry, that's a very big question, but would love to hear your opinion.
And I don't know if it's I don't know how to answer it properly. Yeah, we are currently lack of funding. I think partly because which I feel very guilty about. It's just we don't really make the GBDB what the boss on the top brass expected it should what they expected the GBDB should be. So I think maybe we are disappointed them a little bit because of the slow progress and yeah, blah blah. And I think that's why they don't want to fundingly support the GBDB development like before. So yeah.
Databasing is very slow work, but very worthy work. So hopefully they'll change their minds.
Yeah. Yeah.
Last question for those of you who are still have burning questions, drop them into the chat now. This is your last chance. The last question, the question I've left to last is, oh no, I've just lost it. Oh yes, can people contribute directly to the GBDB? And if so, how would you like them to do that?
One way to contribute to the GBDB is to use the GBDB data. Yeah, I really hope that people see the potential of the GBDB data and start using it. I know downloading it is possible now, but it's maybe some people will find it very annoying to download, because sometimes they will download some incorrect data, so it will annoy people. But where I hope when people did that or come across this kind of problem, just contact us and we can just improve it, because we cannot just two of us researchers in the team cannot cover everything. So this is one that I want people to contribute to the GBDB. Just use the data and also maybe input the data, because as I said, this only China records mostly. I hope people could also use the GBDB to input this kind of stratigraphic records of data and help us improving the input system as well. So yeah.
Fantastic. I'm going to end by thanking you again for joining us and talking about the GBDB. It was absolutely fabulous to hear all about it. And thank you for answering all the questions. And thank you to the audience for your questions. I'll pass over to Liz to introduce next week's speaker and any other details that I might have forgotten.
The next week's speaker will be on the Neptune database, Johan Renaudi, and that is a legacy database. So it has very different issues and concerns and potential to the GBDB. So we look forward to seeing you next week at 1600 CET. So it's a different time slot, same day. Thank you very much.